Take breaks. Taking breaks is an incredibly important part of learning. One of the most commonly cited techniques used by people who are learning on the internet is the Pomodoro technique. Now, this is actually only named after a tomato-shaped timer that the person who invented it used. But it consists of merely setting a 25-minute timer to work and then taking a 5-minute break and then repeating. There's lots of evidence to illustrate that our brain only has a finite learning span and needs breaks. 25 minutes may not be perfect for you. You may find you need less time. You may find you can take more. But trying this and finding out what works well for you is an important part of learning and taking a break. Next, I'd strongly suggest timetabling breaks into your schedule. If you're fortunate enough to have an entire day you can dedicate to learning Python, you'll need to take breaks during that day. There is a reason why schools have breaks as well as a main lunch break. Your brain needs time to take in the information and also needs a rest. I would strongly suggest that you do take a real break. You don't spend the time looking at your favourite Python sites on the internet, no matter how great they are, or reading Hacker News, looking through YouTube, Instagram, etc. Really do take a break. Give your brain a chance to reset. And also, you'll often find that ideas will come to you when you are in this resting state. This is really important. Sleep is also really important for memory formation. Plenty of research has shown that a good night's sleep after a day's learning really helps cement that information and lock it into long-term memory. So if you can, make sure you do get a good night's sleep after you've spent some time studying. And linked to all this, we all know that fresh eyes spot obvious errors. Many has been the time when I've been working on something difficult that I just can't solve. You leave it, the next day you come to it, and instantly the answer comes to you. Or sometimes it just comes to you overnight. Your brain works on things and it will be refreshed during that break. And when you come back to it, many will be the time when you'll see something you just hadn't thought of, and away you go. Become a bug bounty hunter. Bugs are an integral part of programming. Once you move beyond even the simplest program that you create, you'll no doubt encounter this. It can be a frustrating part of the learning experience, but you'll often find it will also be the most rewarding and will teach you the lessons you know the best. Remember, nobody creates code without bugs. The key to finding bugs is to be methodical. It's no use just randomly trying to change things. It's much better to try and get in the mind of what the computer is trying to do and seeing if it really is doing what you think it's doing. Many has been the time when it's looked like it's kind of doing what I think, but actually when I've looked at the details of it, maybe I've got lucky and actually it's much less like what I originally planned. We're going to look at two ways of solving these issues. Firstly, the old school way, favoured by Guido van Rossum, is using print statements. So now you're going to see that in action. The program I'm going to create is fairly simple, and also you may well spot the bug that's present in it. But the idea is really to create a program which is simple to understand rather than create an esoteric, difficult to find bug. Don't worry, you'll have plenty of those to deal with later on. So you're just going to see a simple number guessing game. So the computer is going to think of a number between 1 and 10. Then the user has to guess it, and then the computer will tell the user whether they got it right or not. So here comes the code. I'm going to import the random library to allow us to generate a random number. Print a message for the user. Create the random number. And now we'll let the user input their guess and assign that to the guess variable. Now we're going to check if the guess is the same as the number. And if it is, we'll tell them they were right. And if it's not, we'll tell them they were wrong. There we go, the program's complete, and now you're going to see it in action. So I'm just going to keep running it until the bug makes itself known to us. And there, after many more times than you might have expected, but that's the nature of randomness, we see our bug. It's saying, sorry, the number was 5, not 5. So up to this point, you might have thought your program was working fine, you could have shown it to somebody and been happy about it, and then somebody's going to say, hang on a minute, it said the number was 5, not 5. What's the problem there? So what we need to do is to use a print statement to help us find out what the problem is. So I'm going to insert one here. And now when we rerun the program, what we've just printed out in this case isn't going to help us too much because it's not the representation that's the problem, it's the actual information. So let's look a little deeper. So here we're going to look a little deeper at this and look at what the type is of number and guess. And there we see the problem. The problem is that our number is an int because it's been created by random.randint, but our guess is a string. And when we print strings or ints out, they look identical to us on screen. You may have noticed that wouldn't be the case if you're doing this kind of work in the Python REPL. So it's important to realise that print may not always show you all of the information you need to find subtle bugs such as this, but it can be a really useful and quick method to find out what's going on when a program is running. So in this case, to fix this particular bug, the input needs to be turned into an int. Now this would fail if the user types something which can't be turned into an int, but in this case we'll just leave it as it is to keep it nice and clear. So now when we run the program again, we can see they are both ints, and if I run it enough times to get the guess right, finally we get to a point where the guess was 5, the number was 5, and we can see the program works as intended. Having seen print in action, next, PDB, the Python debugger. So on screen you can see the buggy number guessing program from the previous section, and now I'm going to import PDB to allow us to use it to debug this program. So I've imported PDB at the beginning, and at the point where I want PDB to take over the execution of the program, I put the following line. PDB.setTrace. So as you'll see, the program will run normally until it gets to this point, and then we'll be able to take over step-by-step execution and allow us to look around inside the program as it's still running in memory. So I get to enter the number normally, but now you can see it looks quite different, and the PDB line at the left shows us that PDB has taken over the execution of the program. Now it's really easy to forget where you are in a program, so one of the key instructions to use is L for list, and we can see it's showing us a section of the program. In this case it's saying we're at line 7, and it's the next instruction is going to be if guess is equal to number. But what we can do right now is look at what's in the computer's memory. And it's much like a normal Python shell. If I type number, we can see the value of number. If I type guess, we can see the value of guess. And straight away, this has worked a little better than print because it's indicating to us that this isn't an int, it's a string. So with this one command, we've already found what the problem is. Whereas with print, we needed to delve deeper and manually print out the type of the variables in question. But let's just let the program move on, and we can do that with C for continue. And you see, it runs to the end. It's illustrating that it works normally. Sorry, the number was 8, not 5. And because this is a small, simple program, that's all we need to do. Now, if we put the trace in a different place, we could cheat. Let's take a quick look at that. So now I've put it before I need to put my guess in. So I can cheat, I can look inside the computer's mind, see what it's picked, and then put that number in, which sometimes will be useful to allow you to not have to run the program 10, 15, 20 times, etc. Let's see what number is. We can see number is 9, so now I can continue. It's asking for input, so I'll type in the number 9, and we get the bug. Sorry, the number was 9, not 9. Now again, this is really easy to fix, as you've seen in the previous video, but the idea of this was to give you an idea of how you can use PDB, but also that PDB can be really flexible because you don't have to type out a load of print statements. You can just effectively pause time, look around the computer's memory and work out what's going on without having to put 20 print statements in. And you can step through the program and examine variables each time it comes round. Surround yourself with others who are learning. Surrounding yourself with others who are learning is important in any area where you're trying to learn a new skill, but particularly in programming because the skills are fairly unusual compared to many others in everyday life. There's many ways you can do this. Firstly, local events and meetups. A quick internet search will find if there are any meetups near you that you can go along to. If there are, you'll be able to meet up, find people you can contact either on or offline afterwards, and help boost your learning process. Another great site is the Pythonista Cafe. This is a community of like-minded individuals who are all Python programmers, all interested in improving their skills, and all interested in helping the community. Follow the link for details. Next, PyCon, the annual mecca for Pythonistas. However, if you can't get to the main PyCon, there may well be a local one to you. For instance, I attended PyCon UK last year, and it was a great way to meet people, improve my skills, but also learn that I already had skills which I'd taken slightly for granted. Now that brings me on to the last point, which is imposter syndrome, something that I felt when I first went to PyCon UK. It's that feeling that you don't know enough to be in the room that you're in, and somebody's going to give you a quick test and then throw you out for not knowing enough. In my experience of the Python community, this never happens. Nearly everybody who programs Python loves the language, but also has enough humility to remember that they were a beginner once too. And they're really, really helpful. If you're weak in a certain area, they want to help you rather than show up what you don't know. Also, you may find in situations like this, you actually have more skills in some areas than you may have thought. Everybody has a different set of skills, and you'll have strengths where others have weaknesses.